So, my name is Mrs. Ho, and this is second hour. Okay, this is our last section of the chapter. Today we are talking about applications of equations and inequalities. So, when we have an application is me telling you that we're doing word problems without saying the word problem, because you guys are scared of word problems for some reason, just like you're scared of fractions. But at the end of the day, fractions are just division. And these are just like real world scenarios. And I actually think they're a little bit easier because at the end of the equation, you can stop and ask yourself, does this make any sense? And like pretty much be able to check your answer and know whether you're on the right track or not. So, got a few steps to success for writing and solving equations and inequalities, because we're doing both equations with an equal sign and inequalities with like less thans and greater thans today. So, step one is to define the variable. So that means saying, what does X stand for? Is X the number of ducks? Is X the amount it costs? Is X the cost per, like the first one is going to be cost per donut. Step two is going to be to use that variable in the information that you are given to write an equation or inequality. Write an equation / inequality. Below that, there's a little note. Words like per and each are rates and get multiplied by the variable. Most of the time, our equations equal a total, or we're going to be like less than a total or greater than a total, depending on what the scenario is. But look for those words that say per or each, because most of the time that insinuates that means we're going to do multiplication. Step three is the easy step. Once you've got your equation written, we are going to solve. And step four is to check our answer and add units. Since these are applications, we're not just going to say X equals 7. We're going to say $7 or 7 cats, 7 dogs, whatever the unit is. And then the last thing there with a couple stars by it is to always make sure that your answers make some sort of sense. If our answers don't make sense, then maybe we should rewind and look back at the problem. So if you're trying to figure out how much a donut costs, because that's what we're doing on the first one, and you get that each donut is $7,000, but you knew that your total was $17 and you bought 24 donuts, that doesn't make sense. On many different fronts, that does not make sense. So if you get a ridiculous, wacky answer, stop and slow down and go back and like read through the question and say, does this really make sense? If you get out that it's going to be 1,000 degrees outside, does that really make sense? That's not really that likely. Okay? Any questions right now? Hey, we've got 3 examples on notes, and then we've got 7 problems on your assignment. I'm not sure how long notes and assignment are going to take, and so then once we get these done, we'll decide what we do from there. So, first problem is Annie buys 24 donuts for her class and a coffee for herself for $3.50. Her total is $17.90. We want to know how much each donut cost. So the first thing that we need to do is define our variable. So we are going to write down X equals, what are we trying to figure out? That's that last sentence there. How much each donut costs. So I'm going to write X equals cost per donut.
Why don't we just ask the cashier and not do this whole problem?
Because Annie got to school and she knows she's able to look on her bank account and say, I spent $17.90. And I remember that the coffee was $3.50 because one of her friends was like, hey, how much were these donuts? They're really good. I want to go get some. And she could figure it out if she didn't have a receipt. Look at that. If she knew how much the coffee was, she knew how much her total was.
It would say how much the donut.
But she doesn't have a receipt. She spit her gum into it while she was in the car to drink her coffee. I'm making up this whole scenario. Okay. Anywho, we are now going to write an equation. So, with the word cost per donut, we know that she's buying 24 donuts. So we know that her total is $17.90. So I'm going to go ahead and put that on first. So I'm going to put equal 17.90. We know that she spent money on two things. She spent money on 24 donuts and she spent money on her coffee. So 24 times x, our unknown value, can go first. So we'll have 24x plus 3.50 because we know she spent $3.50 on the coffee. So I've got 24x plus 350 equals 1790. Remember, I'm recording. Okay. From there, we just need to solve. So on today's assignment, you are going to be asked to write and solve. So you do need to write an equation or an inequality for every problem. From here, we can solve. We'll subtract 350 from both sides. We get 24x equals 1440. Hold on just one second. And then we'll divide by 24 on both sides. Do you have the answer for me?
Yeah.
And x equals 0.60.
Yeah.
So in your calculator, you would get 0.6. I'm going to put the 0.60 there because this means 60 cents. So you can either write it as $0.60 or you could write 60 cents.
I've been to a donut shop, but I don't think they sell donuts for 60 cents.
Okay, so at the end of our problem, we add units. So I already added units, so 60 cents. So you can either have the $0.60 or you can have 60 cents. And then we also make sure that that makes sense. We can stop and we can check and we can, in our calculator, we can do, okay, so if she bought 24 donuts for 60 cents, we can do 24 times 0.6 plus the 350 and make sure it checks out. Any questions right now? Okay, we got a couple more. We got one on this side and then we got one on the back. Next one is Tony is saving up money to buy a camera. He has already saved $45 and he makes $42.50 per week. That word per right there is important. How many weeks does Tony have to work in order to earn at least $300 for the camera? So, first thing that we're going to do is define our variable. So in this one, our variable x is going to be the number of weeks he has to work. I'm just going to write x equals weeks. All right. From there, we can write our equation. This is actually going to be an inequality, though, because he doesn't need to make exactly $300. He needs to make at least $300. So it's okay if he makes more than $300. So we are looking to make greater than or equal to 300. Then from there, we're going to write the left side of our inequality. So he's making $42.50 per week. So that's going to go with x, 42.5x. Plus, he already has $45. So we'll add that to his total that he already has. 42.5x plus 45 is greater than or equal to 300. Okay, from there, we can solve. So we're going to subtract 45 from both sides. We'll get 4250x equals, is greater than or equal to, my bad. 300 minus 45 is 255. Then from there, we divide both sides by 42.5. And we get x is greater than or equal to 6.
So 2 months.
In what world is 6 weeks 2 months?
Wait, 1 week is 4.
1 month is 4 weeks.
Okay,
That would be
sorry.
8. Yeah. Okay. So he needs to work at least 6 months. So there's a bunch of different ways that you could write your answer. That would be 6 weeks, not months. It makes 4250 a week, not a month. That would be very little per month. So there's a bunch of different ways you could write your answer. You could write x is greater than or equal to 6 weeks, and you could just leave it there. You could write 6 or more weeks. You could write at least 6 weeks. But we want to know that it's not just 6 weeks. It's not exactly 6 weeks. It's at least 6 weeks. Any questions about that one there? Okay. Go ahead and flip this over. We've got one more problem on the back, just because I couldn't fit all 3 on the front. Okay. This one says fountain drinks are $1.30 each, and chips are $1.75 at the gas station. I made those prices up to make the numbers work nicely. Nathan had $10 and then bought 2 bags of chips. How many fountain drinks can Nathan buy? So, first of all, how much money can Nathan spend? $10. Does he have to spend all 10? No. You can have money and get change back. So we're going to write this. Oh, we need to define our variable first. So x is the number of fountain drinks. So I'm just going to write x equals drinks. I wrote fountain drinks because I couldn't decide whether I wanted to write soda or pop. So I just went with fountain drink. Felt like it was less controversial.
It's scientifically called soda, but some people call it pop, and I don't know why. They're maniacs. And
that's why I wrote fountain drinks, is because I didn't want to start this conversation. Okay, so he can spend less than or equal to $10. Okay, this one has an added little piece. So we know that those fountain drinks are $1.30 each. So we're going to put 1.30x first. And then here's the little added piece. How much has he already spent out of his $10? What has he already bought? He already is definitely going to buy what? 2 bags of chips. So we know that 1 bag of chips is $1.75. So we've got to multiply that by 2. And so we're going to do $1.30x, so 1.30x, plus this $3.50. Has to be less than or equal to 10. So you've got to multiply. So if he's already, so there's like one on your assignment where they've like already bought 4 hamburgers. You got to multiply how much each hamburger costs by 4. Okay, so then we can solve this. We'll subtract 350 from both sides. On the left side, we get 1.30x. $10 minus $3.50 is $6.50. And then we divide by that 1.30. And we get x is less than or equal to 5. And then we can label that with the word drinks. So he can buy 5 or less drinks.
But with tax, most likely.
We're pretending. Do you want to do more math and pretend like tax exists, or do you want to just pretend like tax doesn't exist? We're going to pretend like these are the after-tax prices, okay? Yeah, to make our lives easier. All right, any questions right now? Hey, this can get glued in your notebook, so you can fold it here. Let me zoom out up here. Sorry. So you can fold it there, and you can glue down that piece. So if you glue the back of here, I'll grab my notebook and show you and the video. If you put your glue on this part and then fold it back up, it'll make it so that everything's right side up. It's always my aim in life is to make it so that everything's right side up if you glue it correctly. And if you glue it upside down, YOLO, like, it's really not going to affect anyone other than you, and you can just flip your notebook upside down. So put that there, and then fold it up and lay it flat. And then this will fold up to be able to see the example on the back. You can see the 2 on the front there. Okay. Does anyone need any of the examples anymore? Or can I stop my... Can I turn this off? Anybody need anything? No? Okay, cool. Okay, let me go ahead and stop this video. Bye, video. Nice knowing you, video.